So we've discussed the concept of solubility and electrolytes and described the dissolving process for how a compound can dissolve into its ions. It can be ionized, and then it has different properties. What we want to be able to do is focus on, if we're given a chemical equation, be able to identify what exactly are the species, what ions are reacting, and which ones are not. They're just kind of present. And how can we predict the products based on the reactants? And the process we do to get this is by writing net ionic equations. Net ionic equations. Okay? So the way we're going to walk through this is just by looking at a few examples. Looking at examples is the easiest way, and then you'll get a ton of practice with writing net ionic equations. So, first example, it's on the next page, I apologize. Here's an example problem. A solution of silver nitrate is mixed with a solution of potassium chloride, producing a silver chloride precipitate and potassium nitrate. So what we want to do first is we want to write the molecular equation. Molecular equation. So the molecular equation is the equation that just shows all of the molecules that are present in this process. Okay? So let's start. A solution of silver nitrate. Okay, well, you got to be able to know what nitrate is and know what silver is. Silver always has a +1 charge, so silver nitrate is NO3. We need to include the state, so since it's a solution, this is going to be aqueous. Is mixed with a solution of potassium chloride, so that's just K is group 1, so it's +1, chloride -1, aqueous, because it's a solution. Producing a silver chloride precipitate and potassium nitrate. So silver chloride is going to be AgCl, and since it's a precipitate, it's going to be a solid. Precipitate is a solid. And last but not least, we're going to produce potassium nitrate. So potassium is K, and nitrate is NO3. Well, now I got to think, what is the state going to be? Solid, liquid, gas, or solution? Well, you got to check your solubility rules. In this compound, do I have a group 1 metal or ammonium? Yep, I got potassium. So therefore, it's always soluble, which means this is always going to be aqueous. So I've written the molecular equation. I'm not done. First, I got to check, is it balanced? Well, 1 silver Ag, 1 silver Ag, 1 Cl, 1 Cl, 1 K, 1 K, 1 nitrate, 1 nitrate. Yep, boom, balanced. So my molecular equation is done. The next step is to write the ionic equation. And what an ionic equation shows, the definition to know, an ionic equation shows all of the ions, all of the species that are present in the mixture. So what we need to do to write the ionic equation is take any compound that can ionize and separate it into its ions. So how do I know compounds that can ionize? Solutions can ionize. So for example, AgNO3 can ionize. It can turn into Ag plus, aqueous, and NO3 minus, aqueous. You might be thinking, Shar, how'd you get that it's just -1? Well, nitrate NO3 is -1, that's memorized, so silver must be +1, memorized. Okay, what about the next compound? Can KCl ionize? Yes, it's a solution. So the ions it's going to split into are going to be K, which is a group 1 element, so K plus, aqueous, and Cl minus, aqueous. Okay, let's go to the next compound. AgCl, can this ionize? No, it is a solid, which means it cannot ionize. So we would just write it as AgCl solid. We do not do anything to the solid. Other examples of compounds that can't ionize, gases, so if it says G, or liquids, L, they cannot ionize. What about our last compound? What do we have? KNO3, can this ionize? Yes, it's a solution. So K plus, aqueous, and NO3, aqueous, -1. This is our ionic equation. It shows all of the species present in the reaction in their ion form. Last but not least is to write our net ionic equation. What a net ionic equation shows you is only the species that are involved in the reaction. Again, a net ionic equation only shows the species involved in the reaction. So how do we figure out which ones those are? Well, what we do is we cross out, we cancel species that we see on both the reactants and the product side. So for example, on the reactant side, we have a nitrate, NO3-. We also have the same thing on the product side, so they cancel. K+, potassium, is on both sides. It cancels. Ag+, is there an Ag+ on the other side? No. Is there a Cl- on the other side? No. So all that's left would be Ag+ aqueous plus Cl- aqueous, producing AgCl solid. So this shows us, this net ionic equation shows us the species that are involved in the reaction. Everything else that we crossed out, all of these, the nitrate, the potassium, these species are not involved in the reaction. They have a special name. Species not involved in the reaction are called spectator ions, which means that they're just watching. They're involved, they're in the beaker, they're in the solution, they're swirling around, they're there, but they're not actually involved in the reaction. So you want to know the definition of molecular ionic and net ionic equation, and now we're going to get some, and spectator ions, now we're going to get some practice doing a few more. So, a solution of manganese 2 chloride is mixed with ammonium carbonate, producing a precipitate. So let's do the same thing here. So let's start with our molecular equation. Manganese 2 chloride. So manganese is Mn. It's +2. Chloride is -1. So if I crisscross, this is going to be Mn1 Cl2 aqueous, because it's a solution. Is mixed with ammonium carbonate. Ammonium is NH4 +1. Carbonate is CO3 2-. So if I do a crisscross, I'm going to make NH4 2 CO3 aqueous. And what am I going to make? Well, it says that we're going to make a precipitate. In order to figure out the products that are going to be formed, we need to recognize the metals, the positive cations, are going to switch places. So in this case, NH4 and Mn are going to switch places. So my products are going to be Mn, it's still +2, CO3 is +2, so it's going to stay like that, and NH4 is +1, chlorine is -1, so NH4Cl, ammonium chloride. Now it says which one is a precipitate? Well, I got to check my solubility rules. Let's start with this compound. Does it have a group 1 metal or ammonium in it? Yes, it does. Therefore, that means it's always soluble. So it's going to be aqueous. And manganese carbonate, does it have a group 1 metal or a ammonium? No, it doesn't. So we don't know. But since the problem indicates that a precipitate must be made, and these are the only two compounds formed, this must be the precipitate. It must be the solid, because we know the other one can't be. It has to be aqueous. So we've written the molecular equation. Check. Is it balanced? Well, I have 2 ammoniums on the reactant side, not on the other. So I need a 2 here. Now I have 2 chlorides, 1 Mn, 1 Mn, 1 carbonate, 1 carbonate. Boom. Done. Balanced. Excellent. Next step. We want to write the ionic equation. So remember, split everything that can ionize. So MnCl2, aqueous, it's a solution. Yes, we can ionize it. Mn, what's its charge? Well, it was manganese 2, so it's +2, aqueous. Chloride, Cl2. Now this is one of the most common errors, it's a little bit tricky. When this ionizes, this actually splits into Cl- and Cl-. So So how would we represent that? It doesn't split into a Cl2 molecule. It actually splits into two Cl minuses, aqueous. And I know you might be thinking, wait, but Shar, we talked about the big 7 and the weirdo. Well, that's only true if it's just Cl, not ionized. But since we have Cl with a -1 charge, that rule doesn't hold true. What are the ions present? We have a chloride ion, we have 2 of them. What about the next compound? Well, I have ammonium carbonate, NH4. It's a solution, so it's going to ionize. I have NH4, which I have memorized as +1 charge, and I have 2 of them because of this 2 here. It's distributed out front. Aqueous. And then I have carbonate, which is going to be CO3, 2 minus, memorized. Aqueous. Excellent, I've done my reactants. Now what about my products? Can Mn carbonate, manganese 2 carbonate, can it be ionized? No, it's a solid. So we're just going to leave it as MnCO3 solid. And I'm running a little bit out of room, but let's go ahead and do the last compound. Can it ionize? Yes, it's a solution. So I'm going to have 2 NH4 positives, aqueous, plus 2 Cl minus, aqueous. So there's my ionic equation. Last step is to write my net ionic. And again, my net ionic equation shows only the species involved in the reaction. So I got to cancel out everything that's the same on both sides. So 2 Cl minuses, do I have Cl minuses on the other side? Yes. So these cancel. What about my ammoniums, NH4 plus? I have 2 of them here. Yep, 2 of them here. They cancel. Can I cancel anything else? No, I can't. So I'm left with Mn plus 2 aqueous plus CO3 2 minus aqueous, producing manganese carbonate solid. Boom. This is my net ionic reaction, net ionic equation. It only shows the compounds that are the species that are involved in the reaction. And check yourself, what are all of these called? Exactly. They are called spectator ions. So we'll get a lot of practice done in class with these. I know I might not necessarily be there, but you need to really work on this skill. You'll have the answer keys to go over as many problems as possible.